Hey guys, today I'm going to be talking about the bootloader that comes in your chips, in your little microcontrollers. It comes stock from the factory. In other words, STM programs these bootloaders into their chips. Um, the F1 specifically does not support USB. It has, I believe, I squared C, SPI, and UART. And I'm going to show you how to communicate with the bootloader in this chip through UART, and you can see the output in a serial port monitor. Some of the other chips, I think some of the other F series chips do support USB, so you could just program the chip through USB, which is really convenient. This one doesn't, but there's no reason why you can't write one and make it so. And the thing about writing your own bootloader is that you're not really deleting the bootloader that's in here because this is in ROM. What you're effectively doing is just writing a user application that's going to be take up some space of your available flash, and then your real application is going to have less space. So it is a bootloader, but again, to me a bootloader should belong in ROM. And the other ones that you use, like some people do the Arduino bootloaders on these, and okay, but you're taking up space from your user flash. You're not really making a bootloader that's going into ROM, if that makes any sense. But it works, they work, it's fine, so you just have less space for your program. But anyways, like I said, the bootloader that comes from here, it's in ROM. It doesn't take up your user space, and you're always going to be able to use it. The only thing you need to do to use the bootloader, to get into the bootloader mode, is, if this thing could focus. You see the boot 0 right here, boot 0. You're gonna switch that. You see on this side it says 1, on the other side it says 0. So you're gonna switch the boot 0 to the 1. So you're gonna take this little yellow thing and you're gonna switch it over. The other side, if you could barely read it in between that little switch, it's boot 1. So you're just gonna take this little header and pull it out and just switch it to the other thing, so that boot zero is it's driven high. The datasheet talks about the different boot configurations and how they are set, and we can go ahead and switch our view here. So if we go to memories here, C, let's just look up boot 1. Alright, so here you can see the datasheet telling you, or the reference manual rather, telling you the different configurations. So when both of them are driven low, which is the default state of these two little jumpers that you get here, the default state is to drive both boot 1 and 0 low. You're booting into your main flash. When you set boot 0, right here, when you set boot 0 high, you're going into system memory. And when you set them both high, you're booting into the SRAM. Okay, so that's just how to get into the different boot modes. So what about the actual bootloader? As you can see here, this is application note 2606, and it's telling us that these, like I was just telling you, these bootloaders are in ROM, and this entire paper is just about telling you what the settings are during the bootloader, once you're in the bootloader. So if we look here at the F1 series, right? Again, I'm going to actually repeat the application note so you can download it. It's application note 2606. So you just Google STM32, type in AN2606 in Google, and it'll come up. Okay, so if we go to the F1 series, F10X, yes. You'll see that it's telling us what the configurations are during the bootloader. So once you've enabled the bootloader and you're in bootloader mode, it enables the high-speed external. It sets the frequency to 24 using PLL, and you'll see here that it does use UART1, RX, and TX pin, and it sets, it sets the configurations like you normally would for UART. One thing to note that's very important, because this matters when we are using our COM port, the settings for the UART that it configures it to is going to be 8 bits, right? We know that. However, it does use even parity, so it's going to use even parity. So when we are configuring this COM port to listen to our bootloader, we have to configure it to 8 bits, even parity, and 1 stop bit. Now, so that's really all you're gonna need from this paper, because it just lists all the microcontrollers and all their bootloader settings. The next thing you want to get, oh, not that one, well, yes, that one eventually, but is this one, is application note AN3155. This actually tells you the commands that you can send to the bootloader, how to send the commands, and what the replies are going to be, etc. So there it is. The commands are pretty simple. Command set. So you have, these are the commands and these are the command codes. So this is what you're going to send in the COM terminal to your microcontroller, and it's going to reply with whatever it needs to reply, or it's going to do whatever you tell it to do. So the first command is the get command. I'm not going to go over these because you can read them. And that just gets the version of the bootloader, and it's also going to send you back all of these commands that it supports, right? I'm also going to show you how to use the go command and the erase command. All of these commands are explained right here, what they do and how to use them. Okay, so if we go to the, well, I'm not going to explain that this very second. What I am going to show you is how, okay, to access your obviously the bootloader, I told you have to set this pin to the boot 0 to high, but you have to reset the microcontroller. And I don't mean just press the reset button. You have to actually cut power from it because it needs a hard reset, and plug it back in. Once you cut power from it and plug it back in, it's going to go in boot mode. So as you can see here, my microcontroller is running. It's printing this. I am going to now, first of all, cut the power from it. I am going to move that pin of boot 0, move it to the 1 position, and I'm going to add power to it. And as you can see, now it's not printing anything. So if I can let's switch here. So again, all I did was, maybe I can do it on camera. Darn it, this thing is so tiny. Obviously this is not the one that's plugged in, but here's a little thing. So focus, yeah. So I'm gonna just take this little thing, unplug it from where it's at right now, and I'm gonna just move it to the other side that way. And there it is, right? So now it's boot 0 is high because it's close. This basically, there's 3 pins right here. The middle pin is actually boot 0. One side is ground and one side is high. So this little jumper just shorts boot 0 to high, or shorts it to ground. Alright, so as you can see now, my back to the thing here, my program stopped running, and what I'm going to do is switch to hex mode because it sends everything in hex, and you have to send everything to it in hex. So if you read here on the this little thing that goes with the bootloader, there's a certain command. Okay, another thing, on your COM port here, when you're setting it up, you're gonna do 8-bit. Let me go to it. You're gonna do 8-bit, 1 stop bit, even parity. You could use any baud rate between 1200 and between 1200 and between 5200, because the bootloader will actually I guess it finds a way to actually auto detect whatever baud rate you're using. So you can use any baud rate you want as long as it has 8 bits, even parity, and 1 stop bit. And here's another thing you have to know. For every command that you send, you also send its complement. So what is its complement? It's just the opposite, right? So if I'm going to send the command 00, the complement of that would be FF, right? So the complement for any number, let's say I write the number 12, if you can see here, this is what it is in binary. The complement is just everything that is a 0 becomes a 1, and everything that is a 1 becomes a 0. So when you're sending commands, just the commands, not the actual data you're sending, but just the commands, you send the command here like 00, and you also send the complement. And it actually tells you the complements here when it's explaining the commands, so you don't even have to worry about that. So yeah, so those are the two things I wanted to mention, that you're going to send the command and its complement, and that the UART is parity even. So the other thing you have to do is there's a certain command you have to send it to for it to verify that you indeed want to be in this sort of a bootloader mode, and you have to send it the command 7F. And for this command, you don't have to send the opposite, the complement. I mean, you just send it the 7F command, and it's gonna reply with an acknowledgement. Now, so I'm gonna go through this in just a second here in the video, so you don't have to be confused. An acknowledgement is a hex 79. So every time you send it a command, it's going to reply with a 79 if it acknowledges your command, if it's a good command, or 1F if it's not a good command. Right? So, like I said, we're in bootloader mode. Everything is set. I'm going to send that, not 0. Oh, crap. 7F. Right? That's the command. We're going to tell it to start listening for our command. So this is the first thing you always have to send is 7F. And if it likes this command, it's going to reply 79. So there it is. It replied 79. Alright, so let's go to the get command. The get command is going to be 00, right? That's the get command. And then FF, which is the complement of 00. And again, what the get command does, it's going to return the version, and it's also going to return all of these commands that it supports. So if it supports 1, it's going to return 1, 2, or 3, or whatever. So let's go ahead and do that. So the command is 00, and its complement, which is FF. So I send it, and there you go. Ignore this over here. This side is just this program here trying to turn all these numbers into characters. So just ignore this Y and all this stuff. So I sent it the command 00FF, and it returned an acknowledgement, right? This 0B, I'm not sure what that is. I think that's a break statement or something. But it returned 22, which according to the data sheet, it I don't know if it tells it here or what. It might have been in another one where I read it. That it the number 22 really means 2.2, so it's telling me that this is bootloader version 2.2. So that's what it's returning, the bootloader version. And it's also returning all the commands that it supports. So if we go back to the command set over here, and I open this up, you can see that it supports commands obviously 00, 01, 2, 11, 21, 31, 43. It doesn't support 44. The bootloader will either support this one or this one, but not both. Either supports an erase or an extended erase, but not both. And then 63, 73, 82, 92. And then 79, it's another acknowledge that, hey, I'm done transmitting to you. So that's cool, right? So we're talking to the bootloader. So now let's send it another command. I'm going to send it, as you can see, we're in bootloader mode. So it's not transmitting that hello from Mars message that I have programmed into the chip. So let's try another command. This other command is going to be the go command. So you're going to, and what that does, it jumps to the user application located in the internal flash memory, or SRAM. So the way this go command is going to work is that you're going to send the command go, right, which is 21, with its along with its complement, which is DE. You're going to wait for the acknowledge, which is that 79 value, and then you're going to send the starting address of where your application begins. And as you know, our application begins at address 80800, and then 4 more zeros. So then it's gonna do that, and then it's going to jump to that application. So let's tell the bootloader to jump to our application. So what is it? 21DE, 21DE, 21, and then DE. So we should get a 79. Okay, so it sent us the acknowledge, that it acknowledged the go command. Now we have to tell it where our application is, which is at 08, 2 zeros, and then 4 more zeros. And then we send it. Since it's 4, we send it twice because it's 4 bytes. Now, as you can see, it's printing all this stuff. What is that? Well, that's my Hello from Mars data. So it jumped to my it indeed jumped to my user application. So we are no longer in boot mode. So that's cool. Now let's do the erase command. So I have to go back into bootloader mode, and I can't just reset the pin and it'll be in bootloader mode. I need to it actually has to cut power, and these reset pins on these boards, they don't really cut power to it. I think they just enable the it just loses power via the reset pin. Not loses power, but it just resets the board via the reset pin as opposed to a hard reset. So let's see if we can we're still talking to our guy here. Alright, so we're back in bootloader mode. So we're back in bootloader, and remember, this entire time my ST-Link is not it's not communicating with the ST-Link. I can unplug it right now and it'll be fine. It's communicating through UART, right? Because that's what this thing said, that we were on UART. We're basically using the UART to communicate with it, right? That's why we are in this application, obviously. So I'm going to send it the erase command so it can erase my application. Now to prove that, what I'm going to do is I'm going to connect to my target. So since I still have the ST-Link plugged in, it's still plugged to the board even though we're not using it to communicate. I can see this is my user application, right? Here's the code for my user application. It's there. And that's what I wanted to prove, because now I'm going to go ahead and make the bootloader erase my application, and I'm going to come back to the ST-Link utility, and you'll see that it's going to be gone. So let's look at our erase command. So you're going to send it this byte, or these 2 bytes, 43 and BC. You're going to wait for the acknowledge, and then do you want to do a global erase? If you do, you send it this command, FF and 00. Otherwise, you just send it the addresses of the number of bytes plus the page numbers that you want to delete in your flash. But we're going to do a global erase. We're going to erase the entire thing and see if it works, and maybe I'm not a liar. So that's the ST-Link. Here's my COM port. So clear. So crap, what was that command again? So I want to have the videos. It's 43 BC and then FF00. 43 BC. So we're gonna send it 43 and BC. Uh-oh, it didn't work. What happened? 43 BC. Okay, well, let's try it again. Okay, I know what happened. Because I'm still connected to it with ST-Link, so that obviously negates the whole bootloader thing. So I have to disconnect. Well, now I have to redo the whole thing, right? So there you go. You can't be connected to the chip with ST-Link and be in bootloader at the same time. That's not how it works. But anyways, look, so here's my data. Here's my application node. I have to disconnect from it, and it's going to take that away. Now I'm going to reset the board. Do a power cycle. Let's erase that, and let's try to talk to it again, which is 7F. And there it is. Alright, so now we're going to do that 43 BC again. 43 BC. Okay, so there you go. It sent me the other acknowledge. So now I'm going to send it FF, which is going to be the global, FF and 00, which is going to be the global global erase. So I'm going to do that, and it sent me an acknowledge. That means I acknowledge your command. So now it should have done it, correct? So let's go to ST-Link, and let's connect to our device. And as you can see, everything it's gone. The application code is no here. We have all FFs, and that's it. That's how these microcontrollers are, so that when something is empty or there's no data, it's actually just written to FF. So all my application is gone, and I can go ahead and disconnect from this, and I can you know, prove it to you now that the thing is actually gone. So I'll take it out of bootloader mode, reset my board, and as you can see, there's oops, that's not what I meant to do. There's nothing, my application, it's not there, it's completely gone. So yeah, that's pretty much it. Let me go ahead and upload the application again. Am I connected to the ST link? I hope not. No, I'm not. Modified, whatever. So now that it's there, I reset my board, and now my application is back. And likewise, you should be able to see it here. There it is, no more FFs. So yeah, so that's the bootloader. That's really, I guess, the basics of how it works. This other file I wanted to show you is that if you were to write an application for Windows, let's say, or Python, or whatever you want, kind of application you want to write, to communicate with your chip via the bootloader, to maybe erase it or to upload new code, you know, or whatever it is you need to do. STM provides an API for it, and this application note came in a zip file, and it has the libraries that you can use and that you can talk to and send the same commands that we just sent to do all these other things. But it's actually a library that you can import into your code, and this specific app node is UM0516. Windows API for STM microcontroller bootloaders. So yep, I don't know what else to tell you about that. I think I covered everything. I hope I didn't forget something. So just to reiterate the whole process of doing this, you're communicating with the bootloader. You're switching your bootloader pin to boot 0 to high. You're going to communicate with the chip via its UART connection, not with ST-Link, and that's it. And as you saw, you can't be connected to ST-Link, to the SWD interface and the bootloader at the same time, because it just doesn't work like that. So yep, there you go, guys. Enjoy yourself. Here's another video. I haven't posted the blog for this, but maybe whoever's watching this, by the time you're watching this, I will have posted it. And you can I'll link the files and everything in the description here and in the blog and all of that great stuff. Have a good night, fellas, ladies, gentlemen.